Okay. Hmm. All right. Good evening, everyone. Good evening. Good evening. Um. Okay. All right. Good evening. Hmm. Welcome, everyone. Uh, let's wait for more people to join in. We have just 5 people online now, so let's wait for more people to join in. Let's give about 4 more minutes. Good evening, Mercy. Good evening, Debbie. Good evening, Chidera. Good evening, Happy. How are you? Good evening, love it. All right, please remind your friends, everyone that class is about to get started. Let's get into it today. So 3 more minutes for more people to join in. Good evening, Madam Miracle. How are you? How's your day? Good evening, Evelyn. Two more minutes, 2 more minutes, 2 more minutes, two more minutes. Evelyn, sorry. Oh, I don't envy you. Sorry. When Levina comes, she will send you audio tea that she usually sends. Okay, we have 2 more minutes to get started. Mm. Good evening, Angela Loa. Oh, happy. No mind network on Thursday that did not allow us to have class, Jerry. Okay, 1 minute more. That reminds me, information reaching me is that this is the last lecture week. So you made it thus far, and you can give yourself a round of applause for that. So you've done well. 10 whole week of lectures every 3 times in a week, right? That's about 30 days of lecture, plus or minus 30 days. You've done well. I'm proud of all of you. Yeah, please feel free to clap for yourself or cheer yourself. Thank yourself. Yourself helped yourself. Yeah. All right. So it is 7:05. 7:05. Debbie, I like this your clap. It's back, 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 back. Well done. Well done. All right, so let's quickly get into today's topic. Yes, your exam should be ready by this week. Hopefully, you'll be taking your exam at the end of this week, right? And your project as well. Still looking into the works of it, basically. But yeah, your exam should be ready by the end of this week, so you should be able to take it. Good evening, Falayemi. It's good to see you. All right, today should be not a very long class like that, seeing as is this week is supposed to be kind of soft, right, for us. All right, so can we all see my screen? Please confirm you can see my screen so that we can get started. Debbie, don't worry, God will help you. All right, thank you very much. Okay, so I'm supposed to have updated this. This is what we're supposed to have taken on Thursday, and I forgot to update this title. So we're looking at total cost of ownership and architecting in AWS today. That's what we're going to be looking at. Basically, introduction into each of them. I'm not going to be going very deep dive into it, right? So yeah. So what is total cost of ownership? Remember last week, I think on Monday, right, we spoke about pricing models, we talked about cost optimization, and all of those things, right? So today we're going to be looking at total cost of ownership and how it is different from what we had looked at before, right? So total cost of ownership or TCO, please hope you can all hear me clearly. I feel like my voice is a bit dry or my throat is a bit dry. Yeah, Levina, you're welcome. Please send hot tea to what's her name now? That needs tea. Yeah, for you, Solar Evelyn. Kindly send your audio hot tea that you used to send to us to Evelyn as well. All right, so as I was saying, TCO. Okay, thank you very much, Debbie. Okay, so TCO includes all the costs that is associated with owning and operating IT infrastructure. So everything that um, you need to own an IT infrastructure, to run that IT infrastructure successfully, is the all the costs associated with that, right, is what is known as the total cost of ownership, right? Say for example, if you are building a house, right, your total cost of ownership will be all the cost that is associated with purchasing the land, um, getting the an architect to draw up the design of the house you want to build on the land, right? Buying the materials to build the land, paying the workers that are going to build the land, right? Painting it, setting up the plumbing work, putting in the your televisions, your AC, interior decorations, all of those things, right? So every single thing, and even the cost of maintaining it after you have built the house, right? You need to maintain the house. So all of those costs are what is comes together to be called the total cost of ownership. So basically, everything it takes for you to be able to own this thing. That's what TCO basically is. So in the IT world is every cost that is associated with you owning and operating the IT infrastructure. Now in the cloud, right, the total cost of ownership also is the total cost that is related to your cloud resources, right? Everything associated to you owning resources in the cloud, right? And of course, how it affects or how it has effects on reducing the cost of your on premises infrastructure. Now, comparative total cost of ownership analysis, right, is basically a comparison between how much it is to acquire and to operate an infrastructure on-prem versus how much it costs to acquire and operate an infrastructure in the cloud, in this case AWS. Now, why is it important to actually use TCO? Number one is that comparing the cost of running an entire infrastructure environment on specific workload on-prem or in a co-location facility is going to help you to what budget. Now, if for example um, you are running an infrastructure on your on-prem, you have just one application, right, that you are running in your organization, and you have that application on-prem, and then somebody comes to you as the owner of the company, maybe myself or Mr. Moses comes to you and say, oh, we want you to actually move this application that you have on-prem to AWS cloud, right? It would be kind of foolish of the business owner to just move it without having a cost comparison, right? Now, also note that cost is not the only thing to consider when you are making decision of whether to stay on-prem or to migrate to the cloud, right? Cost is not the only thing that you consider. You also have to consider the efficiency, right, of either of those options. You have to consider uh, what do they call it now? Availability of resources, right? Your ability to scale, um, your fault tolerance. If anything should happen to your on-prem, how prepared are you that it doesn't affect your business, right? So those are some of the reasons why a total cost of ownership analysis is actually done, right? It helps you to have an idea of what your cost is going to be like. It's like if you want to build a house, I think the Bible even says it, right? That who wants to build a house and will not fail for count his cost, right? You have to fail for count your cost. Have an idea. It might not be apple for apple, it might not be exact, but it gives you an estimate, right? That prepares your mind that okay, this is what I'm going to be spending um in the cloud. This is what I'm currently spending on prem, and you can compare and contrast and able to make better decisions. Now, what are the typical TCO considerations? Number one, server cost, right? So on-prem, right? On an on-prem environment in an organization that are still using on-prem environment, when you want to calculate their TCO, these are some of the things that you need to actually consider, right, to calculate, because to have a comparative, it means you have to calculate what they have on-prem versus having a similar thing or the same thing in the cloud. That's what is going to be fair, right? So first thing to consider is server cost, right? How much it will cost to purchase their server, right? Plus how much it will cost to maintain it, how much it will cost to purchase operating systems licenses. Like if your application is running on a Windows operating system, right, you have to purchase a license for the application to work well on that operating system, and how much it will cost to continue to maintain that license. Now, for a lot of organizations, they stop at just these two, right? They don't consider the other ones, like facility, the space you are going to use to put where you put your server. You have to consider that cost. How much you are going to be paying to NEPA, right, for running those servers. You have to do what? Consider that cost. Now, a server room has to be cooled. Like there should be no heat, right? So it has to have ACs, not just big AC now, like standard ACs running to maintain the temperature of those servers. So you have to consider that cost as well. So that is cost for what? For server. The next one is storage cost. So of course, you built an application, right? You bought a server that would host that application on-prem. Of course, you need storage because all the data that the application will be generating has to be stored somewhere. So you also need to purchase your storage disk, right? You also need to purchase a software to back up to storage, and also consider the costs of the space where you put those storage disk, right? The amount you're going to be paying for to NEPA. Now you can say, is it not the same power cost that is in server that should also be in storage? No. If, for example, you are in your house and the only thing that you have, right, is your electric cooker, that's all you have. The amount you are going to be paying for power might just be maybe 15 naira, for example. Now, the moment you bring in a microwave, right, you bring in microwave, microwave will do what? Increase your spend on power. Why? Because it is another thing that is going to be requiring power, isn't it? So that's why you cannot say, oh, maybe they've already considered power here. Why are they considering power here? You need to consider power for both because both of them would need power to do what? To run. Next is networking cost, right? For an on-prem setup, you have to consider how much it will cost you to purchase cables that you're going to use to run your networking to different points, to different systems, to everything. You're going to buy, consider how much it will cost you to also purchase a load balancer, right? You're going to consider how much it will cost you to be monitoring, to purchase the software that you use to be monitoring your network, to know when something is wrong, when something is not wrong. All of those things too will also do what? Take space. Those things will also consume power. They will also need to be what? To be cooled. Next thing to consider, IT labor. Now, this is one major cost that a lot of managers, right, CEOs, they don't used to consider. When you tell them that, oh, move to the cloud, they'll tell you that they've considered their server cost, they've considered their storage cost, they've considered their network cost, and they say that there's no need for them to actually move to the cloud, right? They feel like it's worth it for them to be on-prem. Fine. Have you thought about your labor cost, right? You have a team that has to manage the server. You have your virtualization team managing the operating system, all the licenses and all of those things. You are going to have a storage person. You're going to have your network team who are going to be able to, set up. You're going to have support team, people that are going to, in case anything goes wrong, you can always call on to do what? To fix. Now, the cost of having those people is also something that has to be considered by an organization, right? Then, of course, the extras, the cost of, if you want to buy you want to purchase a new server and all of those things, you have to plan the project. How long will it take for us to purchase the server? Where are we going to order it from? When will this come in? Who will help us set up? You have to put all of those things in place before you now start thinking of the cost of the capital, the amount it will take to even train your people to actually use those things, right? So these are some of the typical considerations for on-prem TCO. Now, of course, you now have to think about business value. If you've developed an application, right, and you need to push it out there, but you've ordered the server and the server is yet to come in from abroad, right, because it's coming from overseas. Something happened to the container that is bringing it on sea. What is going to be the cost of the delay to your business? How competitive will you be compared to your competitors in the same space, in the same industry, when you experience this kind of delays, right? If, for example, you have banks and then one is still using on-prem, their server on-prem is already full, right? They are waiting for the importation of the new one so that they can have more space. And because it is already full, the application is always running slow. Customers are always complaining. I'm trying to use your app. Your application is slow. Your application is this. What's the cost of those customers complaining? If they eventually leave you because your application is slow, simply because you do not have enough space on your on-prem server, right? Or the server did not come in on time, they've now moved to your competitor, maybe Access, you're using Access, you have now moved to Wema because Wema's app is fast. Maybe they are using cloud infrastructure, right? Which if they need to scale, they don't need to go and order any server. All they need to do is go to their management console, right, and launch EC2 instance, right, and then or scale, use auto scaling group to even automatically scale, right? Can you count all of those costs? You need to put a figure to it. That is what will now give you a rounded TCO. All of this is what is going to make up exactly what it is that is costing your organization to actually own and operate an IT infrastructure. All of this. Now, TCO on-prem is not always equal to what it is in the cloud, right? It's not easy, it's not beans, because there are some things that you cannot put a cost to. Debbie likes GT. Oh god. Oh. All right. So as I was saying, there are some things that you cannot put a cost to, basically, right? And so it kind of makes it difficult to have a apple for apple comparison of on-prem and AWS. But of course, there are things that help. So some of the things that are usually included and some that are not included. These are things that are supposed to be included, though, but not all of them are usually included in a TCO, right? For example, infrastructure comparison, that one is always included. If you are running a server on-prem, you can easily compare what the cost of the server would be also in the cloud, right? Capacity planning benefits. There's really people don't organizations don't really take into consideration these aspects, right? How much it costs them to actually have a capacity planning, and what the benefit of those capacity planning is to them as an organization. So those things are not usually included. Cost avoidance is usually included. Workforce productivity. Maybe you see that before, when we're running on-prem, our developers, right, rather than them focusing their energy on building new solutions, they have to also be sharing their time with actually going to go and monitor the server and all of those things. But maybe when you move to the cloud, because they no longer have to manage servers, right, they're able to focus much more on developing solutions that can help your organization. Also, a lot of time to market value is not usually um, included, right? It is supposed to be, but a lot of time they don't do it, right? Because time to time to value or time to market, what that simply means is how much time does it take from when you conceive this idea in your head to when you develop it to when that idea is released to the public or it is implemented for your use, even if you are developing an in-house application, right, that will be used by the employees, maybe not the world, right, or the outsiders, basically. How much time would it take? Some of these things that are important, but they are not usually included in CCO, but it should be. Now, on premises, right, usually compute environment is usually very, very underutilized. And what does that mean? If you have an organization, ABC Limited, right? They are just starting. They've decided that, oh, this organization we're going to be having some applications that will be running. We're going to need this, we're going to need that. So they need to get server, right? That is going to be their compute capacity, right? Now, because they have the mindset that they are going to scale, right? They have the mindset that they would scale. What happens? They usually purchase much more than they need. Even if the application that they want to use at the moment is just 2 vCPU, 4 gig RAM, they believe that, oh, in the nearest future, we are going to grow. So rather than purchasing a server of 2 vCPU, 4 gig RAM, they probably purchase maybe a 64 vCPU, 128 gig RAM. And what will happen? What they'll be using is this. They will now have this amount of space on their server doing nothing, right? Now, this is a code by a study that was done by Gartner, McKinsey, and the Uptime, and they said that typical data centers, they use less than 50% of their compute capacity. Less than 50%. Now, what are some of the questions that you should consider when exploring total cost of ownership? One is capacity planning. How do you plan for capacity? How many servers did you add in the past year? How many are you anticipating to add in the coming year? Right? Can you switch off your hardware on and off and pay for only what you are using? Is that something that is possible for you in your current setup? That's a question you need to do. You need to ask. Two, utilization. Okay, you've gotten to the server. What is your average server utilization? How are you using it? In the 1 year you have been using the utilization, what is your average utilization percentage? How much do you over provision? If you think that, oh, let's say for example, Jumia that used to have Black Friday, right? And they know that on every Black Friday, the traffic will be very crazy to their website, right? Now they don't use cloud. They use, maybe example, I don't work with Jumia, right? Maybe they just use on-prem. Now, even though it is just once in the year that they are going to have that massive peak period, what they would have to do is probably to do what? Over provision. They will have to buy a server, purchase server that can accommodate that period when they are going to have massive traffic to their website. Which means that for every month, or every month, yes, every month of the year, they are underutilizing the server. The only time that that server will probably work to full capacity is only that once in the year when they are having Black Friday. Can you put into cost what those idle times is costing your organization? Three, operation. Will you run out of data center space sometimes in the future? That is possible. Very, very. For an organization, especially if you are going to grow, or if you would grow, you will definitely run out of data space eventually, and then you need to purchase more. What is your current power bill for those data, for running your data centers, for those servers that you have? Some organizations don't have just one server, right? We said data center is uh where you have multiple servers, right? Your data center, what's how much are you paying to run it? How much do you budget for average period and your peak power requirement, right? For those period of like Jumia Black Friday, the amount it will cost them in terms of power, in terms of paying for light bill, right, on that Friday will be much more than how much it will cost them on every other month of the week, because they will even need to have users, right, on their system every time. They have to pay extra time to staffs to always monitor the server, make sure that nothing is wrong, make sure that anything like this, you're there to fix it. All of those costs to operate are things that needs to be considered. And also, even when you're on AWS or on-prem, are you actually cost optimized? On-prem, most of the time, there's no opportunity to actually be cost optimized, because what you're buying are physical structures. You cannot cut them down. You cannot reduce them. If you have bought a server compute capacity of 64 vCPU, 128 gig RAM, and you are only using 4 vCPU, 8 gig RAM, right? It means that you have about 60 vCPU and about 120 gig RAM that is doing nothing. You cannot now take cutlass and cut away that part and go and resell it. You can't do that. Neither can you go and tell another organization to come and put their workload on your own, because I mean you have your own workload too on it, right? So those are the things that needs to be considered. Now, how do customers lower their uh, total cost of operations with AWS, right? Of course, number one is that you are removing that over provisioning attitude. That's I'm planning for the future. Our applications currently need just 4 vCPU, 8 gig RAM, but in the future, I foresee that we are going to need 64 vCPU, 128 gig RAM. In the cloud with AWS, you don't need that. You can always, because of course there's a pay as you go model, there's also even the reserved instance. But let's even say at the moment you don't even know what your utilization is like. You can do a pay as you go model. Start with the 2 vCPU, 4 gig RAM that you currently need. Implement auto scaling so that if at any point you grow, your demand grows, and your compute needs to grow, AWS will help you to do it, automatically scale it. You don't even need to bother, you don't need to order server and then wait for the server to land in Nigeria. Then with AWS, there's something called economies of scale, right? And what does that mean? It means the more people are using this service, the lower AWS brings the cost. If, for example, AWS releases a service today, maybe S3, they just released it, and the cost is $10, right, per gig of storage. And at the moment, it's just 10 people that is using it, right? Now, because AWS has already purchased all of these plenty servers, right? Which means that if it's just 10 people, they're just going to have a lot of idle space. So for it to cover their cost, right, they have to share that the amounts on those 10 people that they have. But when you now have more people joining, maybe you now have 1,000 people that are now using S3, right? Remember that simply what it means is that your data will be sitting in their own data center. So you're going to be occupying more space. So they can now spread the cost more. And then what it will mean is that instead of 10 people sharing the cost and then each person is paying $10 per gig, right? Now we have 1,000 people using this service. It means we can reduce the cost to now $1 per gig for everyone. So there's economies of scale in AWS. There are also different pricing model that you can use, right, in AWS to actually support different workloads. You can implement spot instance. If you see that is a workload that you don't really, it's not something that you need stable compute for, you can afford for it to be interrupted, you can use spot instance and get 90% discounts. Those are things you cannot do on-prem. Of course, the more you grow, the more you save money. Because more you grow, you also even have to implement modernization. You can move from using EC2 to using serverless resources like Lambda that you will only be charged when an event triggers that function. Remember we spoke about Lambda some times ago. So these are some of the things that AWS have in place to help to lower customers' TCO. Now, traditional approach to capacity management, right? And this is for on-prem now. This is to give a visual to what I'd spoken about how on-prem organizations actually over provision. Look at this graph here. This is they are building to peak load, right? Which means like Jumia, for example, for every Black Friday, this is where This is usually their capacity. For every Black Friday, they need about 32 vCPU, 64 gig RAM. Just example, right? That's what they need. So when they are purchasing server, what happens? They will purchase for that period. Now, what will happen? On Sunday, this is what they are using. On Monday, this is what they've used. On Tuesday, this is what they use. On Wednesday, this is what they use. Thursday, this is what they use. Friday, this is what they use. Saturday, this is what they use. Which means that it is only on Wednesday that they are actually doing what? Using this server, this compute, right, to full capacity. On Sundays, all of this is wasting. From here to here is wasting. On Thursday, from here to here is wasting. On Saturday, from here to here is wasting. So all of this gray area are what? Are capacity that they are not using. The only day that they fully utilize their capacity is what? Is on Wednesday. Now, this is when they actually build with their peak period in mind. Now, you as an organization can say, oh, I'm not going to build with peak period in mind. I'm just going to do something small, right? What will happen? You just be that, okay, on an average, this is what we usually get. On an average, we used to need around 4 vCPU, 8 gig RAM on an average. Remember that average is a summation of everything divided by, which means that there will be some figures that will be higher than the average, right? So they've decided that on an average, the capacity that they need is just 4 vCPU, 8 gig RAM. And that's this amount of compute power that they purchased. Their server can only carry that. What happens? On Sunday, they're probably not even using up to that. On Monday, they are using up to that. They are using more than that. Which means that on these 3 days, Monday, Tuesday, Wednesday, when they use much more than the capacity that they have, what will happen? That's when you see that the application is crashing. That's when you will say that, I've been loading this app is not running. The thing is just loading and then to stop loading because it no longer has capacity to actually run the application anymore because you provisioned with the mindset of average. So either way, it is not beneficial to the organization. Whether you are provisioning with peak period in mind or you are provisioning with average load in mind, none of it is beneficial to the organization. There's it's either you are dealing with unused capacity for a very long period of time and you're only fully utilizing your server on very few days, or you are dealing with days where you now have peak period and then you don't have capacity to actually run your application or to run your workload. Now, in AWS, how do you lower over provisioning? Using elasticity, right? We've talked about auto scaling, isn't it? Now, this is basically what it means. Auto scaling is what you are reacting to change. If on Sunday, what you need is 2 vCPU, right? Because remember, there's going to be something that is monitoring. On Sunday, it is only 2 vCPU for 4 gig RAM that you need. It can provision like maybe a 3 vCPU, right? Just in case. So it has this compared to this amount of wastage here. Compared to this amount of wastage here, or compared to this amount of wastage here, right? This is what you have here. So it is the auto scaling will be adapting to the change. On Monday, it has grown. It automatically increases your compute capacity to accommodate Monday's need, right? On Tuesday, it grew again. It automatically did what? Increased it. Now look at Saturday. It is here on Tuesday and Wednesday, right? On Saturday, it says that you no longer need this much. What does it do? It brings it down. It scales it. So in AWS, auto scaling will help you to do what? Adjust to changes. As an organization, right? you don't need to over provision anymore. If there is a need for you to scale up, it will help you to scale up. If there's a need to scale down, it will help you to scale down. And the beautiful thing is that what auto scaling is actually free. To use auto scaling, it is free. The only thing you're going to be paying for is what? Whatever amount of server is going to be adding to your service. And remember that it's going to be adding it for the period that you need it. Once you don't need it anymore, it downsizes, it removes it. Unlike if you need it now, if you are using on-prem and you need to scale up, you go and order the server, you bring it in. When you don't need it again, what will you do to the server? Will you go and auction it? No. To be there, taking up space and being idle. Do you understand what I've said so far before we go into a an example of calculating TCO? Any questions so far? All right, Messi. Thank you. Okay. All right. So let's do a bit of a calculation together, right? So you are an AWS cloud engineer. Hmm? Amen. Amen. All right. So you're an AWS cloud engineer, and then this organization has approached you, or you have gone to meet them. So if you have gone to go and pitch uh, AWS to them, they then tell you that okay, oh, this is what we have presently on our server. We have an application. Now that application receives 10,000 views per day. For our application, we need to run 3 web server that will manage the front end of the application. We need to run 3 application server that will run the back end of the application. We need 2 cache servers for in memory, right? We need 1 load balancer. We need 1 high availability database server. We need storage space of 100 gig, and we transfer about 300 gig of data per month. This is their request. Now, let's do a simple TCO for what it will cost on-prem. Now, what I did, right, is I told, um, because of course I don't have these resources here, right? So I told ChatGPT, I said, give me an estimate of what it will cost to run all those things that I've listed here on-prem. And so he gave this calculation, right? So, they want to know what it will cost, what the total cost of ownership will be for it over a 3-year period. Because sometimes it's not fair to consider just 1 year, right? For some applications, on-prem is better for them in the long run if they are not going to scale so much, because they've already purchased the server in 1 year. If they need to, uh those idle spaces in the second year, they can utilize it again, right? They don't need to go and purchase another server until when that server is full. So they've made initial investments, which can be a good thing, right? So let's look at it over a period of 3 years so we can see what the savings is. So they said they needed 3 web servers, right? Year one, they are going to purchase the server. They will import the server, right? They will purchase, and they will purchase at 15,000 for the servers, for the 3 servers. Year two, okay, let's finish with year one. Year one, for the app servers, the same amount, 15,000. For cache servers, because they are smaller, they need just two, right? $6,000. Load balancer, 8,000, and all the likes like that. Now, year two, they are no longer purchasing server, right? They are only going to be doing what? Maintaining. So, year two, cost of maintaining these web servers, 1.5, right? Cost of maintaining uh app servers, 1.5. Cost of maintaining cache servers, 600. Same thing with year three, right? So, they are doing maintenance. Now, the cost of power year one, the NEPA bill they are going to be paying plus the AC amount it will cost to actually cool those system, $5,000, right? So total at the end of 3 years, the total for web server is $18,000. Total for app server is $18,000. Total for catch server $7,200, and so on and so forth. How much they will pay their IT staff? Remember, we spoke at the beginning that another thing that should be put into consideration, right, is the amount you have to pay people that are running those things, that are managing those things. So you are paying $50,000, isn't it? Now, this brings us to a total of $267,000 over 3 years. Over 3 years space. Now, don't say that it is too high until we look at what AWS own is, right? Until we see what AWS own is. So, total on-prem cost for them running those their specifications, right, that they gave to you as a cloud engineer, the total amount it will cost them for running it for 3 years is $267,000. Now, let's go to AWS. To run it in AWS, right, you don't need to purchase server, isn't it? You're not buying any physical server. You just need to go and launch EC2 instance. Now, you notice that what they needed was what? They needed three what do you call it, web servers and app servers, right? So which means six. So they will need six EC2 instance, right? And the amount for those six is $2,160, right? That's what they will pay year one. Year two is going to be the same thing, right? Year three is going to be the same thing, except maybe they now decide that, oh, we want to do reserved instance in year two. So this one we've not even implemented reserved instance price, right? Now, they also wanted an elastic catch, right? The cost for that is $432. For their database, again, you are not purchasing server by yourself. So the cost of running the database is probably just about $840, right, per year. Load balancer, $240. They will use S3 for their storage, right? S3 will only charge you per gig per um per gig per month, right? Which means that they said they needed 100 gig of storage. So they are paying $27.60 every year for that 100 gig of storage on AWS. Data transfer, they are doing 300 gig data transfer, right? Every month. So $324 per month. All of this cost. Now, see, there is no cost for running IT here. There is no cost for power here, right? There's no cost for licensing here because for a lot of these EC2 services on AWS, rather, they come with license. AWS has already included the license cost with the cost that you're seeing, right? Now, this is AWS, and the total for AWS is coming to $17,612.80. That is about 93% savings. If you go to a client, right, and you present this to them, what do you think the customer would say? What do you think the organization would say? I do. So I do. You should call me investor. Call me investor. If you are the owner of the organization, which one would you go for? Exactly. You go for cloud. Now, so the client will better choose AWS. Exactly. Now, Evelyn, let me correct, right? And that's why I put a caveat in this. A 93% savings is not always going to be realistic. Remember, I said ChatGPT generated this, right? In a real setting, you might not see a 93% savings, right? That is not possible. It is. There are some organizations that they overly provision. It's only 2 vCPU 4 gig RAM that the application need at the moment. They have gone to go and purchase 64 vCPU 128 gig RAM, right? So they just have that they have really over provision and they are not really using it. So in those kind of situations, yes, you can have as much as this 93% savings. But for most organizations, right, the savings will probably be between 30% to 70%. But even with that, a 30% savings is not small, especially when you look at it over the years. It is a huge saving. Now, to talk to Evelyn, right? You say AWS is cheap. It's not. If we're saying cheap in the cost terms of only cost, right? It might not be right. Say for example, I've had a situation where I've gone to go and meet um, a client, and then the client said, "This is how much we want to run our backup. We are currently running the backup at a co-location center, right? We are currently running the backup at a co-location center. This is how much they are paying. How much would it cost to run the same thing in AWS?" And by the time we did the cost estimate, it was more expensive, in quotes, in AWS. Now, why was it more expensive? Because he had not taken into consideration the cost of power. He had not taken into consideration the cost of how much they are paying people to actually manage uh, those servers that they are running. He has not taken into consideration, right, the effects of having empty spaces in their server. So if I just present that estimate to him, he will just tell you that AWS is expensive. Oh, I don't want. That's why you as a cloud engineer, you need to be able to tell your clients, right, not to just look at it from a apple to apple comparison. You need to open their eyes to see that there are other costs that are in play that you are not thinking of as an organization, but they are adding to the bottom line. If, for example, right, like we did this analysis now between the on-prem and AWS, you see that the cost of them running power was taken away, right? The cost of them buying the server was also taken away. So you need to open up, you need to be the one to open their eyes to see, because a lot of them will not want to pay attention to those parts. To them, just like we already have the server, you need to now tell them that, Oga, sir, with all due respect, to have you considered how much your NEPA bill is, especially if your organization is in band A, for those in Nigeria, right? So it is a responsibility as the AWS person to open their eyes to see. And there's one thing that AWS will always say, right? Their aim is not to just pull you to the cloud just for pulling you sake. Your goal is what to offer the most benefit. If, for example, right, the company currently has uh 8 gig, 8 vCPU, 16 gig RAM server rack, and what they are running presently is 2 vCPU, um 4 gig RAM, which means they still have about 6 vCPU and some gig space left. And they need to build another application, and that application is going to take another 2 vCPU, 4 gig RAM. Now, they have space. They still have space on their on-prem, which means that they don't necessarily, in that year, the cost of server will not no longer be incurred by them, right? You going to them now to go and pitch AWS, you cannot be going from a cost perspective anymore. You have to now be going from an efficiency perspective. You have to be going from availability of to more resources in the cloud, time to market value. You have to go from that perspective. And I'm saying this so that you know that when you become, you are employed to an organization that is rendering these services, you need to have more than just cost as your uh as your focal point. Your conversation has to include other benefit aside from cost. Some organizations will tell you, even though they've seen that AWS can give them 30% savings, they'll still tell you that they don't mind spending what they are spending. Until you now tell them that, sir, do you know that for you to the time it will take for you to develop your application, to push it to the market and all of those things, it will be reduced by 50%, or if you do it in AWS, because you're no longer doing long project planning where you have to think of how you are going to import the server, how you are going to do all of this. Yeah, okay. So yes, for like me, not maybe not full understanding, because believe me, there's nothing like full understanding. New things come up every now and then. New things come up, right? Say for example, when we discussed what are they calling it now, data transfer resources, right? And we talked about the snow family, we talked about snow cone, we talked about snowball, and then we talked about snowmobile. If your understanding then is just that, AWS has snowmobile, and you've gone to go and meet a customer, the customer says we want to move about 1 exabyte of data, right, from our on-prem to the cloud. You now say, sir, we have AWS as snowmobile. They'll just bring the truck and transfer the data, and then they move it back. Meanwhile, snowmobile had been disabled in April. You begin to do what? Look stupid to the client. So at every point before going to go and meet someone, you need to read up on that thing. That's what I try to do. Before I go and speak to a client, I know what the client's need is, right? I go to go and read up. So in this area, in this industry, you need to be doing a lot of reading. You need to always be on top of your game, getting new information, following up on what AWS is doing part time, so that you don't go and offer outdated services or solution to customer. There could have been a change in price. You now go and say, and that thing only costs $0.5, oh, and then something has happened. The cost is now one in that particular region that the man wants it. The price is actually $1, but you were looking at the cost for North Virginia region, but the man wants it in Europe West region, and the price is different. Now, this is not me saying this to scare us. This is me saying this to say that in this field, right, you need that determination to go through it. And I'm saying it to us because you stayed this long. A lot of people at from the beginning, when they saw that, oh God, this thing, this I cannot do it, they left. For you to stay this long, it means that you have the grit to do it. So don't fear. It is doable. Amen. Amen. All right. It's almost 8 o'clock, right? And I think Mr. Edwin, can we go for a break now so that when we come back, we'll just finish up with the remaining ones. We're also going to look at um architecting in AWS, return on investment, and if there's a time, we'll look at using AWS pricing calculator. All right, please let's go for a break now. 5 minutes. So it means that we will come back to lecture by 8:05. But in case you have any question at the moment, you can just drop them and I'll be using this break to actually answer. Levina, don't go and eat Eba during this break. All right, please check the description box to get the attendance link. I'm sure we are all used to that by now. I want to believe we will finish before 9 today. Fingers crossed. Yeah, Flyemi. Why, yeah. I know the next phase of this training is the mentorship. So there's still going to be proper coaching and mentorship in the last phase of this training. So those are also things that are in the works as well. So yes, even after that, I'm available. I think you all have access to me on Telegram, so I'm available. I also try and drop my contacts maybe on the very last day of lecture. I'll drop my contact on the Telegram group, so you can send WhatsApp messages as well. 2 minutes more. So now I'm not seeing Levina's message again. Hope they've not taken your light again now. Alright, how many of us are done with the attendance? Just 1 more minute left. Lie on me. It is well with you. Response has been recorded. Alright. Okay, so how many of us are done with the attendance? I want us to finish before 9 today. Let's beat the record. So help me God. Alright. Yeah, I know Loa, it's been a while. How are you, ma? Okay. Alright, Chidera. Okay, so it's 8:05 on Zadot. Alright. Welcome back everyone. Welcome back. Welcome back. Welcome back. Okay, so can we get into it? Are we ready? You're welcome, Anu. Can I fly? Like Mr. Moses would say, can I be flying this night? Okay. All right. Now, thank you, Chidera, as well. Thank you. Okay. Okay. All right. So let's get into it. So we're now return on investments. This is basically simple. Now, at the very beginning of this course, right, I mentioned different different areas, right, of cloud that you can play in. So you can be a salesperson for cloud, right, selling cloud solutions to customer. You can be a technical person. I know some salespeople don't necessarily have all the technical. They just need to know a bit about every AWS service, right? And then when they need to get technical, they pull in the cloud engineer, they pull in the cloud architect to come and continue the conversation. So they are the ones that go out for go and speak to customers. Now, why am I saying this? A salesperson, your responsibility a lot of time, right? Especially for to your customers, to your clients, prospective clients, because organizations are also looking at what am I benefiting from this, right? Yes, you have shown them cost estimate, blah blah blah. What's my return on investment? If I bring, let's even assume that I'm a new organization, I don't have on-prem yet, right? If I'm deciding to invest into AWS, put my resources in AWS, what's going to be my return on investment? So basically, of investment is basically what is measuring the profitability of the organization, right? So it means in the cloud, it basically means the value you are getting, right, compared to what you are spending. What value are you getting compared to what you are spending? So a simple example is if you have put your resources in AWS, right? And what it costs you to put your resources in AWS is $100. And after a year, you did a calculation that if it was not in AWS, so this is how much I would have spent. So AWS has saved my company $200. That means that what AWS has given you return of investment of 100%, right? If you check that, oh, my putting my resources, even though I'm spending $100 in AWS, but I'm not maintaining server, I'm not purchasing server, right? I'm not having to spend money on NEPA bill to run those servers, right? So AWS actually saved me $200, but I'm spending $100. So the difference between the value you are getting and how much you are investing, right, is your return on investment. Now, a a lot of time, right? At the end of 3 years, right, there's a study that says there's about approximately three times benefit, right? So your return on of investment is approximately three times your investment, right? So in this example now, if you invested $1, right, after 36 months, which is 3 years, you've had a benefit of $3.5, right? $3.50. So that's approximately three times what you are investing. Your profits, right, in terms of value of what you are getting, is three times more than what you are putting in. And after 5 years, the benefit is usually about eight times more than what you are investing. Now, what are the tools that you use to calculate total cost of ownership? Number one is pricing calculator, right? You use pricing calculator. Price calculator is basically what gives you detailed estimate of every service, right? You also use migration evaluator. Now, migration evaluator is what you can put in like a customer that has on-prem servers already now, right? They already have running some infrastructure. you can use the migration evaluator to go into their environment. It's like an agent. You install it on their server. It will gather all the information, how much compute they are using, how much storage they are using, if they have a load balancer, all of those things, right? To get all those information. For AWS, right, you can always ask for ongoing now, because total cost of ownership is not something that you just do once, right? It's something that you have to continue reviewing. So you have put it on, you have moved to AWS this year. You need to review, and the tool you can use to review, like we discussed last week, is what? Cost Explorer. And also Trusted Advisor. Trusted Advisor is something that will help you to optimize in AWS. So these are some of the tools that you can use, or that are related to the calculation of total cost of ownership. Is that you're using it to calculate, or you're using it to optimize, or to have an ongoing analysis. Now, I said we're going to do just a very simple example, right, of what the AWS pricing calculator is like. And the beautiful thing about the pricing calculator, it is available to everybody, right? It's available to everybody. Now I need to stop sharing this particular slide, and then share um another one. In me 1 minute. Okay, okay. I'll try and start from the scratch, so that in case you want to practice it as well at home, you can do that. So let me reshare my screen now. Right. Can we see my screen? You should be seeing Google. Is my screen visible? Okay. All right. You can see Google now, Abby. Okay. All right. All right. Thank you. Okay. So I want to start from here, so that you can always follow along and try it on your own later. So, like I said, this tool is available whether you have an AWS account or you don't have an AWS account. All you just need to do is type AWS pricing. You see that it's bringing it out, because I use it a lot. So in my line of work, it's something that I have to use a lot. Pricing calculator. It brings it out. So you click on this particular one, this first one here, AWS pricing calculator. Click on it. Now this is what it looks like, right? It shows you this is how it works. Uh, it will estimate, you add services, you configure the service, then you view the total, right? So you can read all those ones later. Now, when you want to create an estimate, let's assume that our customer has told us that I've built an application, but I want to deploy it on AWS, right? Or I'm confused, I want to deploy on AWS or on-prem. Can you tell me what to cost me to actually deploy it on AWS? He has given you the specification of the application. He has said, oh, the application would need two vCPU, 4 gig RAM of compute. It's going to need S3 buckets to store 100 gig of data, right? So it is your job now. So you click on this, create estimate. Now, when you come here, oh, Let me increase my screen. Is my screen fine? Can we all see it well? Should I zoom in? I think it's fine though. I think it's fine. But let me know. Do you want me to still zoom in a bit? Tina, yes is fine, or yes I should zoom in. Okay, it's fine. All right, thank you very, very much. Okay, all right, so let's move on. So in the on the pricing calculator, you can choose to search for services by region, or choose to search all services, right? Now, this by region, the reason why I prefer to go for this is because there are some services that are not available in some region, right? So depending on, sure, one of the first question I ask customers when they say help me draw up a cost estimate is, number one, do you have a data residency restriction? If they say no, which means that they are not restricted to house their data in Nigeria. If they say no, then the next thing to think about is, okay, where is going to give me, which region will give me the best price, right? And also low latency, which means that it will not still be, my application will not be lagging because the data center is very far away from where I am. So this is the region. You choose which region you want here. Most of the time, if the customer does not restrict me to using Nigeria, right, I usually go for Europe West. Europe West because it is cheaper, right, than if you are going by just latency alone, it's better to use Africa. That's the one in South Africa, right? Better to select this. And okay, we'll do an example and compare the prices for different region. So let's just say the person said he needed a server of 2 vCPU 4 gig RAM. Now, which service do we need to look for to be able to configure 2 vCPU 4 gig RAM? Which service do you need? Let's do this together. Kayode, I have zoomed in a bit. I'm going to know we've discussed this. So if you're the cloud engineer and the customer have said, let me do a cost estimate, right? And you want to cost the resources, and it needs a 2 vCPU 4 gig RAM server. Which AWS service are you costing? Which one? Which one is equivalent to a server in the cloud? Hope people are not going to go and Google it though. Let us not fight. Ah, I expected I would be seeing plenty answers now. This is a service that we have spoken about plenty times. So my question is, the customer says, I want to deploy my application on a server. The server would have 2 vCPU 4 gig RAM. Now you want to come and draw up the estimate. Which service are you going to cost? Which service are you looking for? Is it S3, application migration service, Lambda, or what? Okay, yes, I've seen some answers. Yes. I know it is EC2. Some people wrote their answer and then they deleted it again. Yes, so yes, the answer is EC2 because EC2 is the equivalent of server in the cloud, right? That's your virtual server. So you come here and you type EC2. So it brings out EC2. Now, after you have selected the service, you will now go and configure the service, right? Because there's a particular configuration that the customer gives to you. So you click on configure. Now, When you click on configure, this is where you put in all the specifications you need for that particular server that you want to deploy, so you can get good cost. Number one thing you need to note, this cost is going to be for what? South Africa region, right? Because that's where I have selected. So it's in South Africa. Now, it's going to ask you which type of tenancy. If you remember very well, last week, right, when we're talking, I made mention of shared hosts, shared instances and dedicated hosts, right? Which means a situation where you can, dedicated hosts is you are purchasing the entire server rack, right? And you can put whatever it is that you want there. Do we remember us talking about that last week? Does anyone remember us talking about it last week? I know I'm happy I could not confuse you. I'm glad that I did not confuse you. All right. Thank you very much, Tina. Yes. So you need to select that here. Again, the pricing for, eh, we'll come back to check what the difference in price will be for a dedicated host and a shared instance. So presently we are saying shared instance, right? The customer has told you that the operating system for the application is Windows, for example. So this is presently on Linux, so you need to change it to what? To Windows. So you select. There are other versions of Windows. If the customer tells you, oh, I want a Windows server with SQL, um, with a SQL server, right, together, then you can select this one. But this our customer, our fiction customer, right? As said, is just Windows server in it. So select Windows server. Now, how many instances do you need? One. Also, note here, you can decide to choose. Is it a constant usage? Is it something that's going to be running every time? Is it something that's going to have daily spike? Maybe at 3 p.m. every day, there used to be a spike in traffic. Or is maybe on Thursday, every Thursday, there used to be a spike in traffic. Like that graph that we showed earlier, where on Thursday they used to have increase in traffic to their application, right? Or is it a monthly spike? So you can select which one. But let's assume that we have constant usage, which means that for every day and every week of the kidney, it's kind of constant, at least relatively. So how many instances do we need? We need one. So we put one there. Now, the beautiful thing is, if you know the different instance family, you can come and select. Some customers will give you, they will specifically tell you that, oh, I want the M5 family, right? So you can come and select. But just in case you do not know, you don't have to cram it. He has given you specification that he wants 2 vCPU, 4 gig RAM. So you can come here. It's 2 vCPU they want. Put 2 vCPU. How many gig do they want? How many gig RAM? They want 4 gig RAM. Select 4 gig RAM. When you select this, it will now give you the options available for all of those vCPUs. Now, this is T3 medium, there's T3 large. This is a general purpose instance. This is a compute. This one is also a general purpose, right? But if you look at their network performance, they all vary. For this one, network performance of up to 5 gigabytes, right? And this is the cost for each of them per hour. If I'm focused just solely on cost, right, and I see that the application that the customer needs is not something that needs special compute, right, I can just go for the cheapest one, which is T3 medium. Now, once I click on this T3 medium, look at this bottom here. You see that the price has changed. The price is now $36.35. So this is what we have selected, following the customer's request: 2 vCPU, 4 gig RAM, two $36.35. If you say that it is this one you want to give the customer, right, it is $65.99. So if the customer is big on cost, right, then it's better for you to do what, stick with this one. most of the time my customers are usually big on cost. So except they now want a specialized compute instance family, maybe they want a compute type or memory utilized optimized type. So I've gone with T3 medium. Now you will go down and then you now see payment options. Presently it is on what? Compute savings plan. But this customer is just coming to the cloud, right? Doesn't even know how they're going to be using their application like that. So most times I recommend going with on-demand price. Can you see that the price has increased from $36.35 to $53? So this is the on-demand price for the T3 medium instance that we selected. Now on this place, you can also decide to select if the customer say, oh, I want 100 gig of disk storage, right? EBS is our disk storage, so you can also configure that here. You can do that here, or you can save this one and then go and look for EBS separately and configure it separately. It's all dependent on your choice. But let's assume that this customer did not ask us for EBS, right? We're just doing example. So this is $53, isn't it? Now the beautiful thing about it is it will also show you a calculation of how it achieved this $53. It will tell you that the instance type that you choose per hour, it costs $0, $0.0726 per hour, right? You ordered for just one instance. Now in a month, there are 730 hours, right? So 0.0726 multiplied by that 730 hours, right? Because the what you're saying is the instance is going to be running throughout. You're not stopping it at any point. So that's how we got that $53. So you can always check to show calculation. Now I've seen that we can go back and tell our customer that the cost of running a 2 vCPU 4 gig RAM server in AWS or in South Africa region is $53 if you are using a shared tenancy. Now this same T2, let's now change it to dedicated host. Dedicated host. Now if you notice, when we change it to dedicated host now, can you see that there are no options for smaller ones? Can you see where it started from? If you select, look here now, you cannot see any two kiniko because you cannot be purchasing a dedicated host means you are purchasing the entire server rack, right? And the lowest you can get is a 64 vCPU, and see the cost of it. Let's say we are doing dedicated instance. Dedicated instance is that um even if you stop your instance, right? If you restart it, they must give you that particular server where it was started on before. Before, if you stop your instance and you restart it, they can change the location of the particular server that it was running on in their data center. But when you do dedicated instance, it means you have rent out that particular server alone, not the entire server rack, that particular server alone in their data center, you have rented it out. Right? So let's do Windows, right? It was 2 vCPU 4 gig RAM. Please be taking note of this custom. Now T3 medium, the same T3 medium that we used then for shared tenancy, that was $36, right? $36 and 35 cents per month, right? If you are using a dedicated instance, see the cost, $1,515 per month. $1,515 per month. So you see the difference in cost. Now let's jejely go back to um our shared instance. Please, can we still hear me, Sha? Hope you can all still hear me. Yes, there's no charges for using the pricing calculator. There's no charges for using the pricing calculator. It's free. It's available to everyone. That I say, you can even go on Google to go and look for it. All right. Thank you to everyone that confirmed that they can hear me. So miracle, there's no price attached to doing this cost estimate though. Not that you want to go and run the services themselves in AWS. If that is it, you need an AWS account and you are going to be charged. Although there are some services that are available for you for a period of time for free in AWS. No, the pricing calculator is not, you can access it from the price console, but because it is also a tool that is available to everybody, you can access it directly without logging into AWS console. That's why I started from the beginning. You can just go to Google and type AWS pricing calculator. It will bring it out for you. And then all of these things that I'm doing, trying to get the price, is free. They're not going to charge me for using it. They're not going to charge me for using it. All right. Now we have gone back to our shared instance. Let's go back to, I want to show us the difference between different regions now. So we selected T3 medium, right? So we're back to $36.35 in South African region. Now, if I change this to Ireland, let's say EU West, I've changed the region now from South Africa region to Europe region, specifically Ireland, right? Can you see that the price reduced? Which means the cost of running a T3 medium instance in South Africa is about $4, about 3 point something, right? Dollars more expensive than running it in Europe. So if your customer is much more focused on cost, right? And this Europe will also still give a good enough latency, right? If they are not running a very latency sensitive application, you can just make use of this. I use this most times if the company does not specifically request for Nigeria. So this is how much it will cost. Now, if it is Nigeria that they want to run it, it's T3 medium. Now you see that there might be no T3 medium in our own local zone. So you change this to local zone, right? And then under local zone, search for Africa, Nigeria, Lagos. Okay, so do we have T3? Yes, we still have T3 medium in our local zone. But see the price. The price is what? $39.78 compared to $36 if it was running in South Africa region, compared to $32.70 if it was running in Europe West, right? In the local zone here in Nigeria, it costs 39. So this is a tool you can use to, all you need to do, let's assume that we're sticking with this. You can save and view summary. So it gives you a summary. You can add more services if you want. If you need to add another EC2 instance, you can come here and add. Maybe customer said they wanted another 4 vCPU 8 gig RAM. You can come here and add again, right? So at the end, you view your summary, check everything is fine. You can export the summary. You can export it into PDF. You can export it into a spreadsheet. Do we all get that? Is it understood by everybody? Yes. Now, for choosing of region, remember at the very beginning when we started cloud computing class, we mentioned that there are things that will guide your choice of region. Number one is cost. Number two is latency. In short, number one should not be cost. Number one should be if you have any data restriction law. If, for example, the organization that has hired you is a healthcare organization and they want to put their data center, right? Because there's a law in Nigeria that restricts them from putting their data outside of the shores of Nigeria. You will not now come and do an estimate and estimate Europe and choose Europe region, because that will be going against the customer's data compliance restriction. Now, if the customer does not have any data compliance restriction, which means you can use any region of your choice, the next thing you will now consider is latency. Ask them, this application you want to put, is it very, very latency sensitive? Which means it's something that requires very fast, very, very, very fast response, that you cannot afford for it to lag even 0.0001 milliseconds. You can't afford for it. If they say no, we can still afford a 2 milliseconds lag, right? That will also influence your choice. You can now decide that, okay, I can do Europe, right? Europe to Nigeria, even though it's not the closest, but in terms of price, right? Price will not become your determining factor if the person does not have any data restriction issue, does not have any latency requirements, and cost becomes your your main consideration then. So your choice of region is dependent on majorly those three things. Majorly. All right. So thank you. Let me stop sharing this so that we can quickly get back to our slide and finish up. Um, where is this? Okay. Okay. Let me know when you can see my slide. Can we all see my slide now? Um, Tia, please help me to project my slide. Okay. All right. Thank you very much. Okay. All right. We should be seeing it now. Can we see it now? Architecting in AWS. Can we see that? Okay. All right. Thank you very much, Anola. Okay. So this is another area that I wanted us to have a practical on, but time will not permit to. Since it's our last week, just maybe on Thursday, maybe. If not, we'll, we'll not do it. So basically, what is architecting in AWS? Right. So AWS architecture basically is the design of the cloud infrastructure on AWS to meet business needs. And you consider the compute, storage, security, and networking. Right. Now, why is it important? It's important because it is what helps you to implement um, scalability, reliability, cost effectiveness, and all of those things, and it helps you to be able to meet performance and security requirements. So it means that if a customer have said, "Oh, I want to put my application on AWS," architecting will be you deciding on which instance. It did not give you a specific instance, right? Or they've told you it's just two vCPU, 4 gig RAM server that they need. To be you determining, okay, what we're going to be using is an EC2. They say they need storage. You can say, okay, we're now going to connect it to an S3. We're going to have security group. We're going to be using an internet gateway for the web application, so I can access the internet and people can access the application too from the internet. but our database cannot be sitting in a public subnet. We have to put it in a private subnet so that people will not be able to access our database from the internet. And since the EC2 instance would need to communicate to the uh, or rather, since our database would probably need to get updates from the internet, but we don't want other people to reach it from the internet, we'll probably need a NAT gateway, all of those things, right? Those That is architecting. Now, what are the key principles of architecting? Right. Number one is you should be your architecting should be designed to handle scaling, right? And since we are not on-prem, that you need to over provision, you need to implement things like auto scaling and elastic load balancer, right? You should A very well done architecture is something that ensures that there is high availability, which means you are deploying across multiple availability zone, right? It should be fault tolerant, which also involves reading across multiple availability zones so that in case anything happens to one AZ, the other AZ is still there. Security should be implemented using your security group, encrypting the data and all of those things. Of course, cost optimization, using the best price possible service, right? The best price possible service while still maintaining operational efficiency. Now, this architecting, right? There are diagrams that you fail for develop that gives you a visual of how everything is supposed to operate, right? And there are tools that they use to create this AWS, it's a different cloud architecture, right? All of Lucid Charts, Draw.io, Microsoft Visio, AWS Solution Architect tool. There are tools that you can use to draw these diagrams. I'm rushing through this. Sorry. Now, what is the best practice for your architectural diagram? I'll show you what an architect. A lot of us have seen these architectural diagrams before. Probably just don't know that that's what they are called, right? So, architectural diagram, best practice number one, it has to be clear and simple, right? Your diagram should be very simple and easy to understand, especially for beginners. Don't just overload everywhere with different diagrams. There should be clear labeling. If you have put a EC2 logo, you should label it that this is EC2 instance, right? Follow standard convention. If you are doing an architecture for AWS, make sure that you are using AWS official icons, right? They have icons for EC2 instance, they have icon for security group, they have icon for S3. Like, know that your S3 bucket in AWS is denoted by a bucket, right? They are those icons. So make sure that you use those icons. You can always get those icons online. They are publicly available. Then also let your diagram have a logical flow. If you are going to be doing from left to right, let everything be from left to right. If you are going to be doing from up to down, let everything be from up to down. I'm going to show us an example of an architectural diagram, and I'll use to explain all of this. Number three thing to consider is focus on the audience. If you are drawing up a architectural diagram, right, you need to know who are you those you are going to be showing the diagram to. If it is maybe the finance people or the people that are only interested in the business aspect of the thing, you don't want to make the architecture to be very complex, right? You need to design it in a way that even those that don't have very deep understanding of AWS will still understand what is in your architecture, right? Avoid using jargon. No, jargons are languages that are um, specific to that particular area, right? In as much as you want to use the right term, avoid using very, very complex terms. No, rather than uh, uh, what can I use as a possible example now? No, you want to do the example is keeping my head, but basically what you're trying to say is don't use terms that are difficult for your audience to understand, right? Then very important, very very important, Always show the correlations between everything that you have in the architecture. If you have put EC2 here, you put S3 here, you just put two of them in the architecture. There's no line that is showing that there's any connection between the two of them. How would they understand? So there has to be things that are showing the relationship between each of the components that you have in that architecture. You can use arrows to indicate that, okay, oh, EC2 will be communicating to the S3. Oh, this guy is going to be communicating. So make sure that there are things that are showing relationship. Now, this is the sample architectural diagram we're going to be looking at. Now, this architectural diagram is for a, what you call a three-tier um, uh, three-tier application architecture, right? Which means that they will have a what do they call it now? A web interface, a database interface, and all of those things. They have front end, back end, and everything like that. Now, when you are drawing this diagram, like I said, this is supposed to be live, but we don't have time. This outer box here, you draw it. This is representing what? AWS cloud. Inside the AWS cloud, you have selected your region, right? So you draw another line to represent region, right? You have selected the region. Let's say it is North Virginia region. Now, in that region, you remember that you have to create what? VPC. VPC is your private space, right? For those resources that you want to house. We've spoken about it sometimes in the past. So you create your VPC, right? Now you can see how the VPC is inside the region. The region is inside AWS cloud, isn't it? Now, because you are building for um, availability and fault tolerance, you are deploying this thing in two availability zone. So you have two availability zone: availability zone A, availability zone B, which is represented by this blue box here. Now, inside each of the availability zone, you have your public subnet, you have your private subnet, you have another private subnet. The same thing is replicated in the other availability zone. Now, in this private in this public subnet, you have your security group, you have a NAT gateway. In the private subnet, what is sitting there is an EC2 instance, a security group for that EC2 instance. In the second private subnet, you have your database, RDS, right? You have a security group that is also guarding it for security purpose. Remember, we talked about one of the things to implement is to put in mind, right, when you are architecting in security. Now, you have all of these resources in two availability zone. You have the route table, right? A route table will be attached to all of the subnets that is going to what? Control, like, that is going to serve as a map to different areas, guiding different traffic, right? Okay, this is where you are going. This is the road to get there. Now, if we are doing this thing for availability and fault tolerance, you have what? A auto scaling group. What the job of that auto scaling group will do is that if for any reason this EC2 instance, you can see that it is in between the instance part. If for any reason this EC2 instance gets to full capacity, right, it can add more EC2 instance depending on need, it can shrink it. Now, what the application load balancer is for is that when you have scaled to maybe more than one EC2 instance, it will be the one to decide on, okay, this traffic is going to go here. At this point, this one is having more traffic. Okay, let me direct traffic to this other one that does not have so much traffic, right? So it's one that is going to be balancing your traffic, basically. And of course, there's an internet gateway that is also what? Attached to be able to allow the public subnet to be able to communicate to the internet and to allow these users that are not in AWS environment to communicate to your application that is on AWS. And this is not very, very detailed. A proper live um, setup would have been better to explain this, where we would draw it from scratch, right? I'd even already started drawing it, but NEPA took light and I could not complete it. That would have been the best to be able to use to explain to us. Hopefully on Thursday we'll touch on that, right? But so far, is this, are we clear? Yeah. So Adeshayo, uh what are they calling it? The drawing is for, if you're a solutions architect, your job is actually, you're going to have to do a lot of drawing. If you're um if the area you have selected, you have chosen in cloud, um in the cloud world, right, a solutions architect, you do a lot of drawing of architecture. Now, what are you calling it? A grill that says a grill has no name. You said diagrams are boring. Yes, they can be. But you see, the importance of those diagrams is that it gives you an insight. If you've drawn this diagram now, it gives you an insight into how everything is supposed to go, right? Before you go and start implementing. So that you don't implement finish and that's that, I forgot. I'm supposed to have put the database in private subnet. I've already put it in public subnet and there's now problem. Companies now calling you that outsiders are having access to their database from the internet. You'll be in trouble. So a lot of time there's usually a collaboration, especially if you're working in a very structured organization, right? There's a solutions architect, there's usually a solutions engineer or a systems of administrator, right? Solutions architect will be the one to draw up the architecture and then hand it over to the cloud engineer that would now go and implement it, right? Yeah, Golden Moon, the diagram is not very clear. Like I said, we're supposed to do this live, and so permit me, on Thursday we're going to do it live. We're going to draw it from the scratch. We're going to have a scenario and then we're going to draw from scratch. And you'll be the one to be even giving me, okay, what I was supposed to put here, what I was supposed to put here. Hope I'm forgiving for tonight. We'll do that on Thursday. Are we good? I am forgiving. If you notice the slide, this is, I already started drawing and they were supposed to use this from scratch to explain the architectural diagram, but uh, we had light outage, so I could be power outage, and I could not complete it. So on Thursday, we'll do this from scratch so that you'll be able to better understand the architecture diagram. All right. Okay. So I think, is there any questions, by the way, before I say thank you? Is there any questions? We still have about 7 minutes. I think we kept the time today. Yay. Any questions aside from the diagram? We're going to explain more on the diagram on Thursday. No question. Sorry, I did not have knowledge check today. Like I said, I could not complete my slide because of time. So I now had knowledge check today. Don't worry, you'll have knowledge check on Thursday. So we might probably even do a lot of questions and answers on Thursday to kind of prepare you for the exam. And the exam is virtual. It's online. It's going to be multi choice questions. All right. So maybe on Thursday we'll do a lot of questions and answers, practice possible questions that might come out in your exam. Help us to jog our memory from all the things we have learned from week 1 up till week 10. I'm proud of every one of you. I'm very, very proud of every one of you for making it thus far. And I cannot wait to hear your story of excelling in this field. Olushola, I said it's not clear. Which one is not clear? Did you join late? All right, for the rest of us, I think we're done with the class. We can have a beautiful night's rest. See you on Wednesday at Mr. Moses' class. Love you all. Bye. Olushola, please send me a message. Please send me a message. Yes, Chidera, the exam is later exam. During the mentorship sessions, you most likely be given access to some materials you can use to prepare for AWS Cloud Practitioner exam. Yes, Olushola, like I said, the diagram might not be clear to you this night. As I said, on Thursday, we're going to do it from scratch so that everyone can understand it better. All right. Okay. Thank you, everyone. Good night. Good night. Good night. Good night. Have a wonderful, wonderful, wonderful night rest. Amen. Happy. Amen. God bless you too. All right. Bye. See you on Thursday.